Hello to you all pre-matriculants and welcome to today's maths show, proudly brought to you by Macmillan. I hope you're all pumped up and ready to learn more with us because today we have a special revision lesson on Euclidean geometry. We have selected highlights from lessons shown earlier in the term to help you revise this term's work. You can download your notes for today's show from learnextra.co.za/live. Now, it's time to get on with today's lesson. Please post all your comments and questions on our Facebook page, which is facebook.com/LearnExtra. Or you can also follow us on Twitter @LearnExtra so we can help you with all your revision.
So we've got circle center C with points A, B, and D on the circumference. We've got some parallel lines. AD is parallel to DC. And AD is produced to E. D1 is 108, and we've got to calculate the size of the following angles. So we've got this angle over here is 108, and we've got this line is parallel to this line. And the question is to calculate angle A, C2, C1, and B. If this line is parallel to that, John went through earlier how parallel lines have got a special relationship if we draw the transversal, and that is that the corresponding angles are equal. So that would be 108. Now when you write down the values of the various angles, you need to be able to provide an Euclidean reason. An Euclidean reason is the build-up of the various Euclidean axioms and theorems over the past a few years that you've been working with him. And so it's not sufficient just to be able to write an angle and say, well, that's just because it's that way. You need to give the reason as to what you've used. So in this case, we would say that angle A is equal to angle D1. We would give its value, and then next to it we would say because AB is parallel to DC, and our corresponding angles on parallel lines will therefore be equal. So notice I'm providing a reason for that. Now, this angle on the circumference, this blue angle, is subtended by this arc DC, or DB. But DBs would subtend the angle C1. We need to find out which arc has subtended a circumference angle of 108. And that would be this big angle over here, which is this angle C2. So the pink angle would actually be double what that angle is. So that would be 206 carry 1, so it's 216. So the relationship between the center angle and the circumference angle will always be a 1:2 ratio. But because it's been the major arc that's subtended at circumference, we now can say that C2 is equal to twice of angle A, so it's equal to 216. And the reason that you would provide would be angle at center is 2 times angle at circumference. Okay, there's got to be that explanation that speaks about the theorem that deals with twice the ratio at the center to the circumference. And then finally, if you were going to work out angle C1, C1 just being in a revolution would just be 360 minus 216. So it would just be 360 minus 216, and that would be 144. So this angle here would be 144. And I think that's, yes, and then we could also work out angle B by working inside this shape. You now have A, B, C, D. You could work out angle B by using your 2 angles you've already got in the triangle or in the quadrilateral, and you've got this angle here as well that you can work out. So 360 minus 108, and that would be 252. no, that's not 360. That's 180 because they're adjacent supplementary. Minus 108. That would be 72. So these two are adjacent supplementary. They lie on a straight line. And then this last one, we could now actually say that in a quadrilateral, they all add up to 360. So we're going to take away 108. We're going to take away 144. We're going to take away 72. And in the end, we're left with 36. So this angle over here would be 36 because of my quad. So notice that it's never, you can't ever leave the work you've done previously just in the other grades. You've got to always connect what are the lines doing, what's the relationship to those lines. So we had a pair of adjacent supplementary, plus we had the major arc subtending a major center angle, which subtends half of it at the circumference. And always reminding yourself that you need to have a reason, an Euclidean reason for what you're doing. You can't just say, oh, because I'm calculating the angle. You've got to have a valid geometric reason at calculating those angles. If we have a diameter, then that diameter is going to subtend a 90-degree angle. Why? Because a diameter will have 180 degrees at the center, so when it subtends the circumference, it will be a 90 degrees. So it's a special feature of the diameter. It will subtend a 90-degree angle. In this picture, we have some information with a given diameter, and straight away we can really just expand on that and say that therefore we have a 90 degrees. And we've got this line is parallel to that line. And we've also got that this line is perpendicular. BP is perpendicular to AC. And we've got that B is 35. Okay, what are the questions? We want to find angle A and angle C. Okay. Now I'm sure some of you are already looking at this triangle over here and you're saying, well, if that angle's 90 and that angle's 35, then that angle over here has got to be 55. Okay, so that's angle C2. And while you're sitting on the parallel lines, you're traveling along the lines, and you're saying, okay, here's a little Z shape, so those lines are parallel, which means that the alternate angles will be equal to each other. So that is 55. Now I'm really curious to see how you'd write that up, because it's one thing working on the picture, it's like a puzzle. You get given some information and then you build onto that information, and you can actually work very nicely. But part of your job is to write this up for an examiner who's going to be marking your work, or for a marker who's going to be marking your work. So remind yourself that it's one thing being able to really get excited and working out the puzzle. It's another one, it's another story altogether to actually write it all up. So we're now going to have to set this up and say, well, C2 I know is 55 degrees because I have an angle sum, and there are two triangles in this picture, so we need to label angle sum in triangle DBC. Then we've got the special relationship of the alternate angles. Try and always write the angle that you're trying to find first, and try and write down the angle that it's equal to before you write its value, so that the examiner can see, or the marker can see, that relationship between the angles. And the reason is, always start with the parallel lines, AD parallel to CB, and then the kind of angles that you were working with. Don't just write down alternate angles, because I can give you a diagram. Here's a diagram. The alternate angles are given, but they're not equal. What causes them to be equal is the fact that you have parallel lines. So if you just had to say alternate angles, that's not always true that they are equal. And so write down the parallel lines, because if you forget to write alternate angles, you'll still get the mark. But if you leave out the parallel lines, you may not get the mark. And then finally, what would angle C1 be? Here's angle C1. Well, I don't know C1 and I don't know angle D. And I know some of you are out there and you're putting up your hand and you say, yeah, you know how to work it out, because you've spotted that the fact that this diameter has been drawn, you haven't yet placed the 90 degrees. So it's important to just make sure that if you have a diameter, go to the picture with your fingers, move along that diameter, subtend, and automatically, what you've said earlier, put it on. Do not put on 90 degrees. Don't write it in. Mark off how 90 degrees looks like on your geometry picture. It's so much easier to pick up that these two angles are now complementary and that that angle over here is actually 35. And now that we've got that C1 is 35, I want to make a comment about CBD and CDA. You've done this in grade 9 before. What kind of triangles are these two because of the size of their angles? I'm sure some of you are shouting out and you're posting it on the page, right? You know that they are similar triangles. Why are they similar? Because the size of the angles are all the same. But you can see one is smaller than the other. The size of the sides is different, but the angles are the same, and so we call those similar triangles. How would we write up the C1? Well, the first thing we did was we made D 90 degrees. So D is 90 degrees, and the reason you use is just angle in semicircle. Because this is theorem 3, we have our own rule or our own reason for D being 90, or our own reason for angles subtended by the diameter. We don't have to, in this case, say angle at the center is twice the angle of circumference. Okay, and then the last thing we did was to work out angle C1. And C1 is equal to 180, take away the sum of the other two, which is 90 plus 55, because we know that 3 angles in a triangle add up to 180. Angle sum in triangle. And so C1 is therefore equal to 35. So notice, I've made a deduction, I've given a reason. This is what we call deductive geometry. I'm deducing something, I'm giving an Euclidean reason for it. And then I've used 180. Where does the 180 come from? Because it's the angle sum in the triangle that I'm in. And then I've used, and then I've calculated 35. So the reasons that we're giving are not by calculation or substitution. Those are not mathematical reasons. We are giving some specific reason because of the type of geometry that we are working with.
Welcome back, guys. I hope you're getting into the idea of revision. Please let us know how you are doing, because I'd love to chat to you on Facebook and on Twitter. Enough of the chat, let's get back to revision now.
2 circles, they intersect at A and B, and EAF and DAC are double chords. And it's always important to know why information is given. Why are they telling us that these lines are double chords? Well, if we look at it, it's EAF. It means that EA is a chord in this circle, and then AF continues to be a chord in the other circle. So what they're really saying is that these lines are straight lines. So we've really got that these are straight lines, because we noticed last week that the Euclidean geometry has been built over time, and we can utilize the results we've had previously. And if we don't know certain information, we're not going to be able to proceed. So we can't assume that lines are straight. We've got to be told that they're straight. So indirectly, they're telling us that. They give us the size of 2 angles, and then they say, please won't you find out what the size of DFB is. Now, it's useful to go to DFB and to say, okay, it's this angle I'm talking about, which is really angle F1 plus angle F2. So that we really know where on that picture we're on. Okay, so the first thing to do is to get familiar. Let's get familiar with this picture. We've been told that EAF is a chord, CAD is a chord, so these are straight lines that are intersecting at A. The 2 circles also intersect at B. We've been given these 2 angles. Grade 11s, at the outset, when there's so many lines that are drawn, it's difficult to focus on anything, because those lines are just blurry. They're just all over the place. So the best thing is to always go to the point on the circumference and try and gauge what kind of information do I get from those angles at the circumference. So I'm going to take this first circle, and I'm going to go to point C and point E, and you must use your hands to help you, to guide you, to subtend. You cannot just stare at the piece of paper. You cannot just look at it and hope that it's going to jump out at you. It's not. You actually have to go and use your fingers, use your hands to move along to see how these angles are actually formed. So watch what I'm going to do. If I put my fingers on CE, that means I've got this minor arc, and I'm going to now follow from C and E so that I meet at a point. And can you see that I'm going to A1? Okay, so I can talk about angle A1. But if I go back to CE, I'm always looking for the same chords. I can also subtend at B1. Okay? And I spoke about that earlier, that it's these intersecting lines that create that butterfly theorem. Now, it is important to put your fingers on CE and to go and subtend at the circumference. I can't subtend here because that's not going to give me any relationship between angles. The angles that are related are the ones that are on the circumference. So firstly at A, and then secondly at B. So angle A1 is therefore going to be 31 degrees because they have been subtended by that same arc. So I said to you earlier that all of this, there are too many lines, so we need to focus on one circle. Begin with a circle that perhaps has got the most information. So I know that B1 is already on the circumference and it has 31 degrees. I went for CE because those positions were kind of begging me to kind of go to them and find out what was happening. But grade 11s, you can start at B1. You can say, let's go to B1 and let's see where B1 comes from. Can you see it comes from CE? And now go and find another angle that is subtended from CE. So that would give me that connection. So intersecting lines inside a circle will always give us that focal point to go and look for angles in the same segment. But find the angle, where does it come from? Find another angle that's subtended by that same line. So use your hands like a little maths dance. Okay, so that's 31. Now, earlier we said that this line was intersecting with that line. So if these lines intersect and they're straight, then this A4 and this A1 are vertically opposite angles. All of a sudden, the fact that you've now got this angle is 31, it's given me a cue, it's given me a clue for what to do next. So you need to start somewhere, and you always start with the given information. You always ask, I am given this so that it's my starting point to be able to develop the relationships of the angles in the picture. So go back to it. We started with B1 as 31. We found that it comes from CE. CE also subtends A1, which is 31 degrees. Now, 31 degrees is sitting on the straight lines that I was given, so they are vertically opposite angles. Now we're going to do exactly the same thing. We're going to say A4 now is in the second circle. So A4 is coming from DF. Can you see how I'm using my fingers? DF. DF doesn't only subtend here. Where else does DF subtend? It subtends to B4. So B4 is also 31 degrees. So we started at B1 with 31. We found that it was equal to A1. We found that we had the vertically opposite angles. We then found in another circle that these were equal. At no stage have I actually been looking at where I'm going. I've just been working with what I'm given, and I've developed the various relationships. Now, if I want to try and find this whole angle, I can now say that in this triangle, all I'm missing is this angle D2. So my next question is, could I perhaps find D2? D2 is subtended by BF. BF subtends D2. What other angle does BF subtend? So I can subtend D2 on the circumference. I can also subtend at A3 on the circumference. So it's also equal to angle A3. Well, we can say that this DAC, can you see earlier we were told it's a double chord because it's a straight line. It's a straight line, so this angle is really 82 degrees, I think. because that's 31, that's 67, that adds up to 98, and 98 plus 82 will give me 180. So I needed D2. I was able to find it by using A3. I can now have that as A2, and then in that triangle there, it's obvious that that angle then is 67. So can you see how I've used the multiple theorems to be able to get to that? So now, how do we write that down? It's nice to do it as a puzzle on the diagram, but how do I write it down? Well, I would always start with where I began. So I began with B1 and A1. That's where I started. So always start with the angle that you don't know. So A1 is the one that I found, and it was the same as B1. The one that I'm finding, who's it connected to, and what is its value. So there must always be that link. You cannot just write A1 is equal to 31. Why is that? And the reason is because they're coming off the same chord, they are going to the same segment. So angles in same segment. You don't have to be fancy. A circle was given, so it's just angles in the same segment. Then we found A4, but A4 is also equal to A1, which we now found as 31 degrees. They are vertically opposite angles. And then we've got, let's go too far up, we had that B4 was equal to A4, and B4 was equal to A4, which was equal to 31 degrees. Again, we were using the angles in the same segment. And finally, we found A3, but A3 was equal to 82 degrees because we had a straight angle. And that gave us a clue into D2 as being the same as A3 because it was angles in the same segment. And ultimately, where we really wanted to get to was this angle there, which was really the sum of those two, so that one must be 67. So the angle we were looking for, therefore, F1 plus F2 was equal to 67. Angle sum. And then you've got to specify where you are. The marker's not going to guess where you've been in triangle DFB. All right, this question's very interesting. It comes from last year's supplementary exam, from the grade 12 examination. And it really brings together quite a lot of ideas. And grade 11s, once you've worked with one or two ideas on one diagram, it's important that many lines sometimes are drawn, and we need to focus on those lines that are going to give us some information. So at the start, if I just look at this diagram, there's just lines everywhere, and we need to begin to focus on what's important. And it takes shape once you've been able to read the given. So I would encourage you, as a tip, always read the given once to just get a sense for where the lines are, how many circles you've got, what kind of theorems are being asked. Then you read it again to make sure you've got all the information, because if you miss a diameter or if you miss the center, tickets. You cannot go anywhere if you don't have any information. So it's important to read it a second time. And then when we get so carried away working on the diagram and finding things and so exciting and things are moving, just read it again to make sure that there isn't something lurking there that you've perhaps forgotten and you want to insert, which would actually be useful for some other questions. All right, so here we go. We've got O is the center. Okay, highlight that. O is the center. Without a center, we have no radii. Without a center, we have no diameters. So don't jump into the diagram and say, oh, there's a radius. Be careful. Did you start with a center? So we have a center, and we have a diameter. Got a diameter as well. Chord CF is produced. This is very important language. It's not just sitting there just so that they can waste your time reading. What is produced? What's the effect of produced? It means that we've got a straight line. And with straight lines, we've got straight angles. So we've got that meets chord BF, which has also been produced. Meets chord EB. produced at D. Okay. Chord EC is parallel to chord BF. Oftentimes on the diagram they'll have those, but that's just confirmation. So we've got some parallel lines. This is great. Got lots of information. And then we have also, they've given us one angle to work with, and this is fantastic. If they don't give you an angle to work with, then I would say you introduce some values. It's so much easier to work with geometry when I've got the angles. Okay, so I've got O1, and the most important thing that we read was that O was the center. So who goes from the center to the circumference? The radii, so I have that, would be equal to that, and also equal to this. So I've got 3 radii that are coming off that center. Most important, go to the center. I've got a center angle. It's subtended from CB. It's 2x. Who am I going to find? Angle at the center, I must have its partner at the circumference. Go and find the angle at the circumference. There we go. So angle E is half of that, so angle E must be x. Now, as I move to this new position on the circumference, I notice that this line, or the ray to angle x, is actually parallel. So obviously I'm going to look, who's the partner that's parallel to that? It's that line. Follow the transversal. That means that this angle is also x. Notice how I have not gone to any questions. I have just worked with the given information. You see how important it is. It's giving you all the clues, all the secrets to what's going on in that picture. So don't get all excited and go to the questions. First have a look at what the picture's given us. It's given us so much information. It's given us radii. It's given us an angle at the center, which we have a partner at the circumference. Now we're lying on the parallel line, so we've got some corresponding angles. This is wonderful. Anything else that we notice? Well, let's go and see what else we've got. In the diagram below, AB is a diameter. So AB is a diameter, which means that that's a straight line. So we can also find out what that angle there is if we wanted to. Okay. But we've just learned about cyclic quads. So let's go and see if we've got any of these cyclic quads. I've got E, I've got B, I've got F, and I've got C. So right there, with those 4 points, I've got a cyclic quad. What have we learned about cyclic quads? So let's color them in pink. So I've got C, I've got F, I've got B, I've got E. We've learned that the opposite angles exhibit a special property, that the opposite angles are supplementary. So this angle must be 180 minus x. Okay. Now, that CF we read, CF was produced. CF is produced, which means we have a straight line. If this was not a straight line, this angle here would not be x. That is very interesting, grade 11s, because what deductions do we make? We have 2 angles that are the same in a triangle. What's special about the triangle? Okay, this line is equal to that segment there, okay, because it's isosceles. We've also got that there are another 4 points on the circumference. There's this one here, that one there, that one there, and that one there. So that's also a cyclic quad, which means that its opposite angles are also supplementary, so that angle is x as well. Or can you see how from E we could have subtended to A as well, and those are angles in the same segment, which simply means that we then have that this angle is also equal to x. Okay, now, the most common error that I see with grade 12 geometry when I mark is that they find any 4 points and they say that these angles must be supplementary. So those 2 must be supplementary. The cyclic quad, first go and find it. Go and color in the points and make sure that all 4 points are on the circumference. Because can you see, I'm going to add this angle and that one, and they don't add up to 180. So it means that this quad in here is not cyclic. The 4 points have to be on the circumference. Otherwise, we don't have a cyclic quad. So you need to really look at that. Okay, so if we now look at the questions, determine in terms of exercise of F1, where's F1? Well, we found it. There it is. Did we find that DF was equal to BD? There it is. Did we find that C1 is equal to C3? Well, we found that C1 plus C2 was equal to X. And the question is, could we say something about C2 and C3? Could we say something about that, that angle over there? And perhaps if we did a little bit of thinking, it would come from that original cyclic quad, remember that pink one, would be to say, well, I do know that if I produce, okay, I'm going to highlight it in green. So let's just highlight, okay, that doesn't work. Let's just undo that. Let's highlight it in yellow. So if we just outline the cyclic quad there, if we produce one of its sides, we create an exterior angle. And the exterior angle will be equal to the interior opposite angle. So that's also equal to x. So you've got C2 plus C3 is equal to x. And you've got C1 plus C2 is equal to x. The two totals are the same. Therefore, they've got a common angle. Therefore, C1 must be equal to C3. So just a little bit of thinking around there. But lots of cyclic quads and lots of working with the properties of the cyclic quads. Two circles intersect at B and A. CBD is a double chord. CSE and DTE are drawn to meet BA produced in E, and SA and AT are drawn. So all that information there is just a position for us where each of the points are, where each of the lines are, and it's not given us anything interesting. There's no center, there's no diameter, there's nothing to work with. There's just lines, okay? Then they've also given us that B1 is X and A4 is equal to Y, and we need to prove that this shape is actually a cyclic quad. So let us go to the shape. Everybody, take your colored pen. We're all going to do this together. SATE, and we're going to outline that shape. So SATE. Okay. And we've got, as I said, CBD is a double chord. Why are they giving us that information? Because CB is a straight line. CB is a chord in the circle. BD is a chord in that circle. They're not congruent circles. They haven't talked about that, so we can't assume that. But they've given us that B1 and A4 is equal to Y. And we've got no other information. If we go back to it and we just read it again, they intersect. We've got a double chord. We've got those lines that are drawn to meet BA produced. So BA is produced. BA is produced, which means that that's 180 minus Y. Okay. And now we want to prove that that blue shape, it can be cyclic. Meaning, we want to prove that ASET, those 4 points, could lie on the circumference of the circle. What did we do just a few minutes ago? We found 3 ways of proving it's cyclic. Either its opposite angles must add up to 180, or its exterior angle must equal to its interior angle, or the diagonals must subtend equal angles. Well, there have been no diagonals drawn, so I'm not going to go that route. But if I took ES as being produced to C, then can you see that S1 is the exterior angle, and the interior angle has got to be opposite it. So this would be adjacent to it. This would be on the same line. Opposite means it's got to be directly the opposite vertex. So the 2 vertices have got to be opposite each other. So if you put your fingers on there, you'll see that they're opposite. These are not opposite. They are adjacent. These points are on the same line. So make sure that, okay, that's an option for us. We can work with that if we wanted to. And then if we go to what's given, okay, so that's where we're going. If we look at what's been given, we go C, B, A, S. Ah, what is that? Those points on the circumference. C, B, A, S on the circumference. So what kind of shape is that? There are on the circle. So C, B, A, S is a cyclic quad. If it is cyclic, then what do we know? That its opposite angles are supplementary. So that gives me that that angle is 180 minus x. Okay? And we've also got that this line is straight. So how much is this angle over here? That's also x. Okay. And we're going to write down as many angles as we possibly can. We're also given that this is a double chord, so if this one's x, how big is B2? 180 minus x. Okay, now I was in CBAS as my cyclic quad. I've now moved into this angle here, which is in another circle. So let's see if we can find some cyclic quads there, because this geometry is all about cyclic quads. So there's a point, there's a point, there's a point, there's a point. So this one's also cyclic. And if that is cyclic, then this angle over here is equal to x. And this angle over here, it must be 180 minus x. So it really didn't matter which route we took. We could have shown that the exterior there is equal to the interior opposite, which it is, or we could have shown that the pair is opposite, is supplementary, or we could have shown that that angle is equal to that angle. So there's actually 3 different ways of actually finding that is cyclic. Okay, so now if we had to just write it up, where did we start? Okay, we started off with either that as being supplementary because we needed to get to T1, or we could have said we could have started with this angle over here. So if you want to go with B1 and S1, you would write S1 is equal to 180 minus B1, the relationship. And the reason that we use is opposite angles in cyclic quad. But because there were 2 there, you need to mention which one. So be specific, CBAS. Okay? And that would mean, therefore, that S1 is 180 minus x. If we had then said that B2 was 180 minus x because of the straight angle, then we can automatically say that T1 is 180 minus B2 because opposite angles in cyclic quad, and in this case we have BD 80, and therefore T1 is equal to 108 is equal to x. And looking at T1 and S2, we can then say for S2 is equal to x, these would be the same, and therefore that blue shape is a cyclic quad. And I'll leave you to work on why is STDC a cyclic quadrilateral. Okay.
Welcome back from the break. I can't believe that spring is here and soon it'll be time to plan for your final exams. Don't stress, exam school is coming in term 4. We'll be here to support you all the way. But for now, let's get back to our revision lesson.
I've taken the question from this year's supplementary examination from the grade 12 paper, which used to be paper 3, has now been incorporated. For those grade 11s, if you're doing geometry, you can go through all the 2008 to the 2012 exam papers and find paper 3 on the Gauteng website, and you'll find quite a lot of examples to practice on paper 3. Right, so in the diagram we have some information, and part of doing geometry is being able to read the given and not missing any of the given. So we have O is the center. This is very critical because centers give us so much information. It gives us angle at the center. It can give us some radii. It can also give us a diameter. So all these parts of the circle will ultimately enable us to connect various angles together and to link them in some way. So that center is a very powerful thing. We've also got here's something that's quite important as well. We've got PKR is a tangent. We're looking for those words because what do we know about tangents? We have tangents are perpendicular to radii or diameters. We have the angle between tangent and chord, which we've just done a moment ago. And we've also got, if we have more than one tangent, if we've got two tangents, it gives us an isosceles triangle. So center, tangent, they are what we call loaded words. They've got lots of activity about them that we've got to go and put on the diagram. We've got a given angle. We've got OUV is 48. Often these bits of information are placed on the diagram, but we're going to go and have a look to see if they're there. Okay, OUV is 48, as I expected, and KTU is 120. Now, last week we learned about cyclic quads, and we said that in cyclic quads, we would have that the opposite angles are supplementary. So my guess is that this angle would be 60 degrees. Mindsetters, would you agree that that is true? That those angles would be supplementary because we've got a cyclic quad. The 4 points are on the circle. Is that true? One of the biggest errors that geometry students make is to kind of work with the theorems that they've learned and apply it anywhere and everywhere. They do not look for the conditions under which those theorems exist. So I've posed something to you. I've said, are those angles supplementary? I'm hoping that back home, wherever you are, that you are actually jumping up and saying, no, that is not right. Those angles aren't supplementary because a cyclic quad only exists when the 4 points are on the circumference. So if we start counting U, T, K, O, U's on the circumference, T's on the circumference, K's on, but not O. So therefore we do not have a cyclic quad. We would have to have all 4 points. So U, T, K, V are in fact 4 points on the circumference. So grade 11th, here's a tip. You want to be able to identify your points being on the circumference because all the theorems are about some position on the circumference. So if you're not on the circumference, forget it. These theorems are not going to work. So first focus. Where are my points on the circumference? Where are my angles on the circumference? Then the second thing you do is to see if there's a center, because a center angle is related to the circumference angle. But any other angles are really not connected through the circle theorems that we've done. So let's go and have a look just what I mean. If we go here, you'll see. Can you see this angle C is at the circumference, D is at the circumference, C is at the circumference, C is at the circumference, and all these angles over here, E, F, A, they're all at the circumference. So where do I begin when I start doing geometry? With the circumference. Okay. So I was really trying to identify whether you are with me on this. Yes, U's on the circumference. Yes, T. Yes, K. O's not at the circumference. So O cannot be 60. So let's take that away. And let's go back. Let's go back to seeing what we have then. So back to the given. O is the center. Okay, mark it. We've said that the radii, we would have radii. So that line there would be the same as that one. Okay, imagine that's like a little puzzle and you're putting all these things that you know on the diagram. We've also got that the circle K to UV. So they're already giving you that these 4 points are on the circumference. If they are, then this figure is a cyclic quad. So VK TU is cyclic. What do we know about cyclic quads? We know that the opposite angles are supplementary, and we know something about the exterior angle. Okay, so we now have definitely that V is now the 60 degrees, and earlier on, circles are very predictable shapes where you can see the size of the angle. It's not possible that this obtuse looking angle would be 60, because I think that's very deceiving. A diagram won't give you the exact sizing of the angle, but it's got to be within its range. So if it's acute, it's an acute size. If it's obtuse, an obtuse size. So it didn't make sense for us to make that 60 earlier on. Okay, so we've got that as 60. Then What else do they give us? We've got a tangent, right. The next thing that you do, what color did I make it? Yellow, is that we would like to color in our tangent, and we would like to write on the diagram that it's a tangent so that we don't forget to go and fetch that information from it. It's very easy to read it, to go onto the diagram, to see so many lines. There's 1, 2, 3, 4, 5, 6 lines there, and to completely ignore the fact that it's a tangent, and I've got this information about this tangent that I need to put on. So the first thing is I would have my tangent, and I would say, well, if I'm choosing that as a tangent and I choose this one as a chord, remember you've got the choice here. If I choose that as a chord, then I put my fingers on the chord and I subtend into the opposite segment. I know that this angle is equal to that one. I'm not going to put it on just now because I want to show you some more angles, but I certainly know that's equal. But I can go from the other side as well and choose that as my chord, meeting at K. If I choose that as the chord, then I'm going to subtend all the way to U2 and this 48 degrees. And if I choose this as a chord, then I can subtend all the way to V, and so this angle over here is also 60 degrees. Okay, so whichever way you want to look at it, you're going to have many chords that are meeting there, and it's about, in fact, that one's not a chord, that's a radius. You've got 1, 2, 3 chords meeting there, so you're going to have 3 angles between tan and chord that you've got to just be aware that you could be using. So it's information that's available to you. We have a diagram with a tangent where we've labeled it. We've got a center that we've marked off the radii. We've been given that angle as 48 and that as 120. We've identified that we've got a cyclic quad, so the opposite angles are 120. And we're now ready to calculate angles. The first one is V, which we've done already. Now remember that geometry requires you to be able to give reasons for what you're doing. So you would say angle T plus angle V is equal to 120 degrees. Why am I saying 120 when it's actually 180? And that's because it's the opposite angles of the cyclic quad. Angles of cyclic quad. Then that would give us a V of 60 degrees. Okay, next one is KOU. KOU is this angle, and KOU comes from the circumference. I'm not changing my circumference, I'm subtending to the circle, and therefore there's a 1 to 2 relationship. The angle at the center is always double the angle at circumference. So that would be 120 degrees. So that would be KOU. Now, watch grade 11s. Just watch very carefully. You've now got the center angle, and you've got an isosceles triangle. We call this the apex angle because it's the angle sandwiched between the two equal sides. If that happens, if you've got an isosceles triangle, it's obvious that this angle over here must be 30 and 30, because the base angles of your isosceles triangle are equal, and my triangle has got 180 degrees, so I can find U2. And if you look at the next question, it was exactly that. We had to find U2. K1 is now this angle. Now, the moment you go to K1, you can see that it's sitting on that tangent. So there must be a relationship between the tangent and the chord. And remember what we said earlier. Choose your chord. K1 makes K is sitting on VK. If you subtend, you go nowhere. So we've got to actually not use that chord, but we've got to use the chord that will subtend that angle. So it's actually that chord as well, because I can actually subtend that way, and I would get this angle that would be equal to it. So K1 is actually the sum of those two. There's my tangent. My chord subtends to it. Just draw a proper tangent. There we go. Let's just finish off. There we go. That's better. Highlighting the tangent. Then from that chord, subtend to that angle. So 78 degrees is what that angle there is, angle between tan and chord. And then lastly, K2, how big is angle K2? That would be this one here. Let's just color it in there. There we go. This angle here. How could we work that angle out? Well, we've got this 48, we've got that 30, we've got that 30, we've got that 60. It's the remaining angle of that big triangle. So we've got that going there.
Grade 11s, we have come to the end of today's show, but thanks to Macmillan for making this possible, and thank you for joining us and for participating in this revision session. Remember to always visit our website, learnextra.co.za/live. That's where you can get all the notes and watch our videos. If you're stuck on any questions, make sure you post them on helpdesk at learnextra.co.za/helpdesk. And don't forget, learning is the only thing the mind never exhausts, never regrets, and never fears. Keep learning. Peace.
And the question is to calculate angle A, C2, C1, and B. If this line is parallel to that, John went through earlier how parallel lines have got a special relationship if we draw the transversal, and that is that the corresponding angles are equal. So that would be 108. Now when you write down the values of the various angles, you need to be able to provide an Euclidean reason. And Euclidean reason is the build-up of the various Euclidean axioms and theorems over the past a few years that you've been working with him. And so it's not sufficient just to be able to write an angle and say, well, that's just because it's that way. You need to give the reason as to what you've used. So in this case, we would say that angle A is equal to angle angle D1. We would give its value, and then next to it we would say because AB is parallel to DC, and our corresponding angles on parallel lines will therefore be equal. So notice I'm providing a reason for that. Now, this angle on the circumference, this blue angle, is subtended by this arc DC, or DB. But C1 just being in a revolution would just be 360 minus 216. So it would just be 360 minus 216, and that would be 144. So this angle here would be 144. And I think that's, yes, and then we could also work out angle B by working inside this shape. You now have A, B, C, D. You could work out angle B by using your two angles you've already got in the triangle or in the quadrilateral, and you've got this angle here as well that you can work out. So 360 minus 108, and that would be 252. No, that's not 360. That's 180 because they're adjacent supplementary. Minus 108. That would be 72. So these two are adjacent supplementary. They're on a straight line. And then this last one, we could now actually say that in a quadrilateral, they all add up to 360. So we're going to take away 108. We're going to take away 144. We're going to take away 72. And in the end, we're left with 36. So this angle over here would be 36 because of my quad. So notice that it's never, you can't ever leave the work you've done previously just in the other grades. You've got to always connect what are the lines doing, what's the relationship to those lines. So we had a pair of adjacent supplementary, plus we had the major arc subtending a major center angle, which subtends half of it at the circumference. And always reminding yourself that you need to have a reason, an Euclidean reason for what you're doing. You can't just say, oh, because I'm calculating the angle. You've got to have a valid geometric reason at calculating those angles. If we have a diameter, then that diameter is going to subtend a 90-degree angle. Why? Because the diameter will have 180 degrees at the center, so when it subtends the circumference, it will be a 90 degrees. So it's a special feature of the diameter. It will subtend a 90-degree angle. In this picture, we have some information with a given diameter, and straight away we can really just expand on that and say that therefore we have a 90 degrees, and we've got this line
Hello to you all pre-matriculants and welcome to today's maths show, proudly brought to you by Macmillan. I hope you're all pumped up and ready to learn more with us because today we have a special revision lesson on Euclidean geometry. We have selected highlights from lessons shown earlier in the term to help you revise this term's work. You can download your notes for today's show from learnextra.co.za/live. Now, it's time to get on with today's lesson. Please post all your comments and questions on our Facebook page, which is facebook.com/LearnExtra. Or you can also follow us on Twitter @LearnExtra so we can help you with all your revision.
So we've got circle center C with points A, B, and D on the circumference. We've got some parallel lines. AD is parallel to DC, and AD is produced to E. D1 is 108, and we've got to calculate the size of the following angles. So we've got this angle over here is 108, and we've got this line is parallel to this line. B's would subtend the angle C1. We need to find out which arc has subtended a circumference angle of 108. And that would be this big angle over here, which is this angle C2. So the pink angle would actually be double what that angle is. So that would be 206 carry 1, so it's 216. So the relationship between the center angle and the circumference angle will always be a 1:2 ratio. But because it's been the major arc that's subtended at circumference, we now can say that C2 is equal to twice of angle A, so it's equal to 216. And the reason that you would provide would be angle at center is 2 times angle at circumference. Okay, there's got to be that explanation that speaks about the theorem that deals with twice the ratio at the center to the circumference. And then finally, if you were going to work out angle C1,